This is the interim presentation for the analysis and redesign of a can opener. As seen here, this is the production volume for the can opener. Given the growing demand for can openers and the CAGR of 5.2%, there's an estimated global annual production of 3.15 million units.
The CAD for the can opener was obtained from GrabCAD. On the left is the can opener with all its parts in the final assembled position, and on the right is the exploded view with part numbers and labels for all non-fastener parts. The primary customers for the can opener are ordinary household members who need to be able to open canned goods that do not contain a pull tab to use for eating, cooking, or baking. The secondary customers are those who are elderly or physically impaired who do not possess the same grip strength as most people. The can opener will be adjusted to have longer pivot and crank handles and softer grips to require less torque to open the can and for increased comfort.
And here's the fast diagram of the can opener. The primary function is to open a can. And to do this, your can opener must first stabilize the can. To stabilize the can opener grips the can and maintains alignment. And to grip the can opener applies pressure and maintains pressure. Another sub-function is to cut the can. And to cut the can opener rotates the can and pierces the can. The can opener also enhances the product by adding comfort and ensuring cleanliness.
Next, we'll be proposing 2 assembly sequences. For each sequence, we've made a fishbone diagram that flows from left to right. The first assembly sequence begins with the lower frame pivot, then it goes into the gear and cutting mechanism. This assembly finishes with the rest of the housing and the upper and lower grips. The second assembly focuses on external components first. In this case, we'll start with the upper frame pivot, the upper handle grip into the lower frame, into the lower handle grip, and then we go into the gear and cutting mechanisms. As we can see from the sequence comparison table, sequence 1 is more advantageous due to its ease of transferring and handling, ease of assembling in parallel, and ease of testing sub-assemblies.
The function component mapping matrix contains all the can opener parts along with the functions that each part performs in the can opening process. For example, the upper and lower frame pivots maintain alignment and apply and maintain pressure. The upper and lower gears with their pins work to rotate the can and maintain pressure. The blade is used to pierce the can, while the upper and lower grips help to maintain alignment and add comfort.
Here's our bill of materials. To calculate the cost of the components, we assumed an annual production rate of 500,000 units per year. Material, processing, and tooling costs were determined using similar parts found on custompart.net. The assembly cost was calculated based on the assumption that the work would be done in the United States with an $18 hourly pay rate. Regarding manufacturing processes, injection molding and CNC machining were the most used, with die casting following closely behind. The parts that we plan to purchase are the spacers and fasteners. The total production cost of the can opener is $23.79, slightly exceeding the standard market price for a typical manual can opener, which is around $20. Here, we organize the components based on cost and their functional importance. Based on this analysis, we recommend redesigning the can rotating gear wheel, lower gear, upper gear, and the can cutting blade due to their high processing costs.
We see in the function differentiation table what differs between customer segments in relation to functional requirements are the applying pressure, maintaining pressure, and rotating the can. These correspond in the component commonality table to the upper handle grip, lower handle grip, upper gear, lower gear, and the crank handle as modules.
These are the 2 variants for the primary and secondary consumers. In the modified version for the secondary consumers, the gears are enlarged, so less torque is required to rotate the can, therefore making it easier to operate. The crank is also enlarged in size and has an added grip to allow for holding onto it more easily. And finally, the handles are larger and overall more ergonomic for those that may be physically impaired.
We see here that the common interfaces are the upper and lower frame pivots, which allow for the insert of the grip handles, and these have variant modules. The pin holding the crank handle and the upper gear to the upper frame pivots is also a common interface, and the pin holding the lower gear to the lower handle pivot is another common interface.
This is our product family assembly diagram. As you can see, due to the fact that the gears need to be assembled in a particular sequence in order for the can opener to work, we weren't able to delay differentiation very much. However, further optimization of our design can allow for us to delay differentiation and make for a more efficient assembly process.